So in this lesson of Year 11 Chemistry, we'll be going over how we approach and answer mole calculation questions. So before we even do that, let's have a quick intro to what a mole is. Now if a pair is 2 and a dozen is 12, then a mole represents 6.022 times 10 to the power of 23 of a substance. Now this is a very large number, so we need to start fathoming what this value actually entails. So to put it in perspective, 1 mole of money is enough money for everyone on Earth to spend $1 million every hour for the rest of their life. 1 mole of seconds is equivalent to 19 quadrillion years. That's about 1 million times the age of the universe. So I understand this is a very large number, and the reason we use very large units of measurement rather than a dozen, for example, in chemistry is because we're studying the very small. We're looking at molecules and atoms. And due to their small size, there are so many of them that we must quantify them in much larger groups. So now let's look into a practice mole calculation question. The typical question you can get in Year 11 is you've been given the mass of one substance in a reaction, and you're asked to find the mass of another substance in the same reaction. Now I have a set of steps to ensure that you always get these questions correct. The first step I always do is I write the chemical reaction. Now there are 2 things I always do when I'm writing a chemical reaction. Step 1, I always look to balance. Step 2, I always look for states. Now once I've written my chemical reaction, I've got my basic cooking recipe to answer this question. So now I just have to fill it in with the data. So step 2 is converting the language of this question into its raw important data. Step 3 is whenever you're stuck, find the number of moles. These 3 steps have gotten me out of every single mole calculation question in Year 11 and Year 12 HSC Chemistry. So let's delve into this question. I am going to start by writing my equation, which is hydrochloric acid combines with sodium to form 2 products. Now, this is an acid-metal reaction. So you always form a salt and hydrogen gas. And the way I always know my salt is I look at the negative ion of the acid. Since the negative ion is a chloride ion, the positive ion must intuitively be the metal itself. So the salt here is sodium chloride, and hydrogen gas is also released. So now I'm going to write my states. So the state of an acid is always aqueous. That is because acids are often dissolved in water. The state of the sodium is solid. And the salt is formed in the aqueous solution of acid, and in this specific case, it dissolves, so it's aqueous. Now to balance it, I simply look, there are 2 hydrogens on the right, 1 on the left. So I'm going to put a 2 here. And since there are 2 chlorides on the left, I'm going to balance that. Now since there are 2 sodiums on the right, I'm going to balance that on the left. So now I have a balanced chemical reaction with states. Let's put in our data. Now very simply put, we're finding the mass of the salt. So the mass of the sodium chloride is what we are trying to calculate. And we have the mass of sodium. Now remember, whenever you're stuck, the first thing you do is convert mass to number of moles. So you must know this high yield equation, which is the number of moles is equal to mass over molar mass. Always write the general equation first in chemistry. So the number of moles of sodium is equal to its mass, which is 2, over its molar mass, which is 22.99. And that should give you a value of 0.08699, which we are going to store as A. If you round it off here, your final answer is going to be rounded off even more and may be considered incorrect by the marker. So let's keep it stored as A. Now, once I found the number of moles of one substance in this chemical reaction, if I want to find the number of moles of any other product or reagent, I must apply the stoichiometric ratio. So what does that mean? Now, I think of every chemical reaction as a cooking recipe. So it tells me that I need 2 parts of acid to combine with 2 parts of metal to form 2 parts of salt and 1 part of hydrogen. Now the 2s and the 1s all represent the parts in this cooking recipe. And the parts are synonymous with moles. So 2 moles of acid combined with 2 moles of metal to form 2 moles of salt. So I've been given that the number of moles of metal is listed right here. So to apply the stoichiometric ratio, I simply write what I want over what I have. And that is a simple way to apply the stoichiometric ratio. Now, what do I want? I want the number of moles of sodium chloride, because then I can find its mass. I have the number of moles of sodium. And I know that the numbers in front of both of them are 2 and 2. So right in front of sodium chloride, I'm going to put the number in front of it, which was a 2. And right in front of sodium, its stoichiometric ratio is also 2. So that simplifies to 1. So that simply tells me the number of moles of sodium chloride is equal to the number of moles of sodium, which is equal to A. Now I know the number of moles of sodium chloride. Can I find its mass? Yes, the number of moles is always equal to mass over molar mass. So the mass of sodium chloride is simply number of moles times molar mass. Do not skip this step. This is where students make silly mistakes. You want to always write your general equation, then sub in. So, to go back here, this is equal to A times 22.99, which is a molar mass of sodium, plus 35.45, which is a molar mass of chloride. And that should give you a final answer of about 5.083 grams. And is that our final answer in chemistry? No. So here, the minimum amount of sig figs in this question is 1. So that means my answer must also be to 1 significant figure, because the question is already inaccurate. So my answer can only be as accurate as the least accurate value in the question. So then I have to round this off to 1 sig fig, which is simply 5 grams. And that is how you answer this question. So to quickly recap, equation, data, and find moles. And don't forget the very important tip, which is how to apply the stoichiometric ratio. Put what you want over what you have. And make sure you're using the stoichiometric ratio here. And that concludes this lesson.